Welcome. These are the week 1 notes for career math. This recording will cover sections 1 through 1-3. Okay. So first off, we want to start with basic operations on the number line and ordering numbers. As much as this makes sense, sometimes it's the symbols that don't. So we know that as we move to the right on the number line, numbers get bigger. We know that 2 is bigger than 1 and 3 is bigger than 2. If you notice, 0 kind of cuts the number line in half, and then when we go to the opposite side, negatives are in reverse order. Okay, sometimes that helps to think of when we are trying to order anything further to the right is larger. Okay, so anything up here is larger. It is cumbersome sometimes to think about which symbol means what, so I'm going to give you my very mathy way. If I'm comparing A and B, and in bold it says A is less than B, I know that B is bigger. And so because I'm a grown-up, I am going to use the fish here, and the fish always eats the bigger number. So don't worry so much about how to say it, just which direction the symbol goes. So strictly less than, strictly greater than are the two symbols we have up here. You will notice that there's also the option for less than or equal to, greater than or equal to. The less than and greater than part are the same as what we've just talked about. The equal to part is just the little line underneath. Okay. That means the number can be less than or it can be equal to, but definitely not going to be both of those at the same time. So take a minute to do the example here. Fill in the correct symbol for A and B. I know that 8 is greater than 5, so I know the open end goes towards the 8. I could have put greater than or equal to, but we know they're not equal. For B, I'm going to combine these numbers first so I know that I'm comparing the right things. I have 9 and 14. 14 is bigger, so my inequality opens towards the 14. This is basic. I'm assuming that a lot of this is just a review. Keep in mind you can go to the textbooks and the video provided there if you need more. Exponents. So when we are working with unknowns, we use a variable. That just means we don't know what the number is, or we want to be able to substitute in different numbers. Okay. In terms of exponential notation, this large number down here is called a base. The exponent, the little number up here, our exponent, or our power, tells us how many times we multiply that base. So for A, I've got 4 times 4 times 4. The base is 4, that's the number I'm multiplying. The exponent is 3, that's the counter on how many times that number is being multiplied. Because we want to simplify it, we always multiply that out. 4 times 4 times 4 is 64. Okay. B is an important one because those negatives can get in our way sometimes. I got -6 quantity squared. That means I'm multiplying -6 times -6. A negative times a negative is always a positive. We get a positive 36 for that one. That is different than C, which says -6 squared. So order of operations, which order here we will talk about next, says we do the exponent first before we multiply. And this negative out front is basically multiplying by -1. So this means negative 6 squared, which is a negative positive 6 times positive 6, which gives us a negative 36. So be careful where that negative is and how the parentheses are involved. D says 4 times 3 squared. This exponent only applies to what it's attached to, only applies to the 3. So this is 4 times 3 times 3. We can multiply in any order. We still get 36. For E, because that 4 times 3 is in the parentheses, we are actually going to multiply that part first before we square. We get 12 times 12 here, which is 144. So pay attention to where those parentheses are happening and what that exponent is attached to. Talk about radicals. We have a way to use exponents. We got to have a way to go backwards. This little number up here is called the index. If there is no number there, we assume it's a square root. We don't have to assume anything. Okay, the square root symbol itself, this is called the radical. The number underneath is called the radicand. Sometimes I'll call it the argument. It's what we're applying the root to, the square root, the cube root, whatever. Okay. Gray box explains fractional exponents. We don't need to worry about that so much right now. But what a root is asking for the number that you can multiply by itself to get that argument. So 25 I know I can rewrite as 5 times 5. Square root of 25 is 5. B, that negative on the outside, works the same way as it did a minute ago. It happens after you apply the square root. So the negative square root of 25 is going to be -5. With fractions, we can split that into parts. Square root of 64 over square root of 81. Sometimes that helps. Square root of 64 is 8. Square root of 81 is 9. That means 8/9 times 8/9 would give us 64 over 81. Because we work in a base 10 system, we know how many tens we're multiplying by how many zeros there are in the number. Square root of 100 is the square root of 10 times 10, which is just 10. Square root of 10,000, let's see, 2 zeros here, 2 zeros here. Square root of 10,000 is 100. E looks a little different, and while I don't think there are any like this in the homework, it's important to understand the property is the same. Remember that I said that even though there's not an index up here, it's a 2 because we use square root more than anything else. It is possible to need a cube root, and that's what that little 3 means. That means what number can I multiply by itself to get 27? So I'm going to go through steps here. 27 is 3 times 9. There's my 3 times. 9 I can rewrite as 3 times 3. Cube root of 27 is going to be 3 because I multiply 3 times to get 27. Maybe I should use a different number so there aren't so many 3s. Last section here covers order of operations, one of the things that I know was hammered into you in middle school and high school. This setup looks a little different. Sorry, this is why the notes are late. I can't get rid of this cough. A lot of times we use the acronym PEMDAS. Problem with this is that it looks like multiplication should come before division. Actually, multiplication and division are two different versions of each other. So are addition and subtraction. So parentheses always happens first. We combine anything we can in parentheses. Then our exponents. When we get to multiplication, it honestly goes left to right. Whatever you see first happens first. And then the same thing with addition, left to right. Okay. So when we look at A here, 6 divided by 3 plus 2 to the third times 5. I'm going to take care of, so let's go through our checklist. There are no parentheses. Exponents. I do have exponents, and let me see if I can color code here. So my exponents match up. I'm going to take care of this 2 to the third first. That's 2 times 2 times 2, which would be 8. And so I'm going to replace that 2 to the third with the 8, because that's all it means. It's the same thing. Now I'm going to go to the multiplication and division, but I got to go left to right. So you notice the 6 divided by 3 is first. I'm going to replace that with 2, because that's what 6 divided by 3 is. Then I have this multiplication here, 8 times 5. That's 40, and the plus stays in the middle. I have not done anything with that yet. So now I add. 2 plus 40 is 42. Okay. Now I'm going to go through B. I'm going to color code this one as well, and this will be the last one I color code because I'm guessing you don't want to watch that over and over. Let's see. I know there's a yellow in here. So parentheses, I am going to take care of simplifying what's in the parentheses first. I get 14. I'm just rewriting everything else. That's my first step. Now I'm going to the multiplication and division step. Sorry, I skipped over exponents. There are no exponents, which is why I skipped over it. So now I'm going to the multiplication and division step. Notice this divide by 7 happens first. So I'm going to do that part. 14 divided by 7 is 2. I'm going to replace the 14 divided by 7 with the 2. And then I'm just going to recopy the rest of that expression. I got 2 times 3. There's a multiplication. 6. And 6 minus 6, which is 0. This would be a great time, spacing's off there, sorry, to pause the recording, go through these next couple and do them, go through C and D, and then come back and check your answer. Okay. So we're back. Important to remember that that division bar kind of works like parentheses. It's like having parentheses around the numerator and around the denominator. So I'm going to do those first. In my numerator, I've got 4 plus 3 squared. I got to take care of that exponent. 3 to the second is 3 times 3, which is 9. And in the denominator, I have 6 minus 5 times 3. I got to do the multiplication first. That's 15. My 6 minus stays in there. 4 plus 9 is 13. 6 minus 15 is negative 9. I'm taking away something bigger from something smaller. I get a negative answer. And we are going to cover this, but that negative can be moved anywhere. That's going to be the same as negative 13 over positive 9, or negative quantity 13 over 9. As long as there's one negative, it doesn't matter where I put it. D gets a little more complicated. So again, parentheses around the numerator, parentheses around the denominator. I'm going to take care of the exponent first. That negative's going to stay out front, But this part right here means -3 times -3 times -3. Whenever I multiply an odd number of negatives, my answer is going to be negative. I get -27 there. Plus -5. I'm going to do these multiplications. 2 times -8 is -16. I got a minus. 5 times 3 is 15. And we will talk about integers more fully later on. This is kind of a refresher to see what you remember. -27 is +27. Plus -5 is the same as -5. -16 minus 15, -31. I get 22 over -31. Again, I'm just going to pull the negative out front. If this is not a review, if you're not plugging it into, it's perfectly fine to use a calculator to do things. The reason for talking about this is making sure you plug it into the calculator correctly. Okay. Last piece, evaluating expressions. This is telling me that x is -2, y is 5, and z is -3. So I'm going to plug those in where they belong. My x is -2. So -2 is going to go in everywhere I have an x. I don't know why that happened. Minus 7 times my y is 5. So I'm going to replace everywhere there's a y with the 5. Notice I'm wrapping this in parentheses. 7y means 7 times y. Can't just tack it on to the end. And our z is -3. So right there. I got 4 times -3. Now, even though I've wrapped these numbers in parentheses, there's really nothing to do in the parentheses. So I'm going to go to exponents next. -2 times -2 is +4. And just so I'm doing all the multiplication at the same time, I'm going to just rewrite this all. -4 times 4 is -16. Minus 7 times 5 is 35. Plus 4 times 3 is plus -12. I can write that as -12. When I combine all these, I get -63, and sometimes I have trouble thinking and talking at the same time. So somebody please double check and let me know if I did that wrong. I think I'm okay. B, same thing. I got 2, -2 minus 5, plus 4 times 5. I'm going to assume you're okay with the order of operations. We are just going to plug in here. Oh, I forgot a square. And simplify till I run out of room. I got to combine steps. I got 2, -7 times -7 is 49. We get 98 plus 20. I'm going to combine down here and make this a 1. Now I'm just going to add the 98 plus 20. That gives me 118 over 1. We don't ever really need to write the over 1 part. And right now we're going to skip C because we don't need to worry about something that intense.